Okay, when you describe data, two things usually, the central tendency and variation. Central tendency, we use many times like a mean. So mean means where it is most sample or population dense. And then the variation is how dispersed. So when you measure central tendency, we usually use the mean, average, median, and mode. Mean, you may know, just add all members and divide by the number of members. The most common measure of central tendency, all the values play an equal role. That means when we get average or mean, it's like that. So if member is 5, the value is 5, 10, 15, then add all member divided by the number of member equals 10. Then to make 10, they contribute 33.3% to make this one. So their members' role to make this mean or average is the same, equal role. And then a balance point in a set of data. So 10 is like this, balance point. And then the sum of deviation from the mean is 0. If mean is 10, then first member depart from mean -5, and then this one depart +5. So mean is like this one is like a deviation, how far from mean. So means deviation is 0, and then how far like this. So that is the mean. And then, as you know, just add all of them divided by number of sample or number of population. So sample, later I will tell about that. Sample mean and population mean different notation. Sample mean is X bar. And this one, mu, is population mean. So sample mean, just add all of them divided by sample size, like this. So example, add all of them, divide by 10, and so on. And then when we say weighted mean, each member's role may be different. Depending on like how important. So here example, when we calculate grade, then like a policy, grading policy, like the attendance 10%, midterm is 30%, final 40%, such assessment is 20%, like that. Then if a student got score 100 out of 100, 90 out of 180, 70, like that, then 100 times 0.1 and 0.3, 0.4, 0.2. So they are weight, depending on how important. So this case, final is the most important. factor and midterm and assessment and attendance. So using different weight calculate. So that is the weighted average. So each member's role may be different like this. So another example, the car construction company pays is hourly employees at $16, 50 cents, $19, or 25 per hour. And then maybe they are based on their skill or experience. Then 26 hourly employees, among them 14 receive 1650, 10, 19 to 25. So times like this, and then divided by members. So these members kind of role, weight, these members role or weight, and so on, divided by total number, and this one. So this is an example of weighted average or mean. And next one is the median, the middle value in a set of data that has been ranked from smallest to largest. So median is kind of physical middle point. The mean, earlier one, arithmetic mean, the value, the balance point. This is an arithmetic balance point or midpoint, but the median is physical midpoint. And then to get a median, using this formula, sample size plus 1 divided by 2 ranked value. So to get median, we need sort data from smallest to largest, and then give them rank like this. And then using the formula, sample size is 7 plus 1 divided by 2. So 8 divided by 2 equals 4. Fourth ranked value is this one. So in this data set, median is 22.4. Rule 1, if there are an odd number, the sample size is odd number, then plus 1 divided by 2 is whole number. So just use that number. But if the sample size is an even number, then plus 1 divided by 2, always 0.5. So this case, rule number 2, add 2 adjacent number divided by 2. So this case, 0.5, 5.5, so between 5 and 6. So add 2 adjacent numbers, 39 plus 40 divided by 2 equals 39.5. So this case, in this data set, 39.5 is median. And next one, the mode. Mode is most frequent number. Frequently appear number. So in this data set, 29 ounce, 31 ounce, 35 ounce, 39 twice, and others appear only once. So in this data set, 39 is mode. Maybe there is no mode if all members appear the same number once like this, or twice, or the same number of appearance, then there is no mode. Maybe 2 or more modes in data set 39, 39, 44, 44. So there are 2 modes, 39 and 44. Variance. When we invest in like a stock or something, then if their return on investment, like a ROI, is like 10%. Average ROI is 10%. Type A, B stock, then the range is like this, negative 10%, 20%, the same average, but worst case, like 5%, 30%. And then let's say 15%. So if the economic condition is not good, so the maximum ROI is 30%, A stock, but the economic condition is not good, then negative 10% like that. But stock B, good condition 15, bad condition 5% like that. Then even there, A and B, average ROI is the same, but because the range is different, like 10 here, 30, and negative 10, and here 5 and 15. So range is like this. So depending on their characteristic or something, if the investors, the investment like risk takers, maybe take this one, but then risk averters maybe take this one. So if we know only average or mean, then we cannot evaluate which one is better. But if we have a range like this, then we can decide based on their characteristic like this. So that is a variation, and then we can use range, we can use variance, we can use standard deviation. First, range. Range is largest maximum minus smallest minimum. So in this data set, 52 minus 29, so 23, that is range. And variance and standard deviation measures the average scatter around the mean. So mean is from the example, like mean here 10, and then the first one distribution looks like this, second one looks like this, 32 minus 10, 5, 2, 15. So around mean, how they scatter. So this one dense, and then this one is like a wide, like this. That is the variance. Population variance. Notation is, this one is the sigma square. That is sum of each member minus population mean and square divided by the population size. That is population variance. Standard deviation, population standard deviation notation is sigma equals square root of variance. Sample variance notation is S square, the same, sum of each member minus sample mean and square divided by sample size minus 1. We call this degree of freedom because sample size, when we use sample, predict population, then make conservation, we use 1 minus 1. And then sample standard deviation notation is just S and square root of the sample variance. So if we use calculation using that formula, then we need difference between each member minus sample mean. So sample mean is add all divided by the number of the sample size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 39.6. So 39 minus 39.6 equals negative 0.6, and so on. And then we need a square and add all divided by n minus 1. N is 10, so minus 1 is 9. So this is sample variance. And then take square root, that is sample standard deviation. So notation, population and sample mean looks like this. Population mean, we can read this as mu, 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 x bar, sample mean, and population variance, sigma square, and then s square, standard deviation, population, sigma, and sample standard deviation, s. And then describe data graphically. One of them is dot plot. Using dot and then pile up if there is multiple, the same value. So using that, we can show data set like this. So 23 dot here, 27 here, and then another 27 pile up and so on. So if we draw line like this, so we can show data using dot plot, then looks like distribution. And next one is stem and leaf. Using number, looks like similar to dot plot. Tens and single here, single digit. So 35, 43, 43, 48, 48, 49, 49, and 54, 55, 55, 59. So using number instead of dot, we can show our data. So this one also can draw like this. Then looks like a distribution. So we call this tens, stem, and single digit here, leaf. So we call this stem and leaf method to show data or describe data graphically. Quartiles. The standard deviation is the most widely used measure of dispersion. So using number, we can show how disperse. But using these quartiles, we can show that how disperse graphically. And quartile is like a data set, divide data set into 4 sections equally, physically. So first quartile, second quartile, and third quartile. The first quartile, Q1 equals sample size plus 1 divided by 4 ranked value. This one is similar to find median physically. And then first quartile means it's like the boundary. From that boundary, smallest 25%, and then larger than that boundary, 75%. Like this, 25 and 75%. And second quartile, this one is the same as the median. So to find the median for second quartile, 2 times n plus 1 divided by 4, that is the same as the median, the formula to find the median ranked value. So median is the same from this boundary, 50% small and then 50% large than this point. And third quartile, divide 75% small and then 25% larger than that boundary. Q3 equals 3 times n plus 1 divided by 4 ranked value. And then some rules. If the result is a whole number, then choose that ranked value. No problem. So if Q1 is 7 plus 1 divided by 4, 8 divided by 4, second ranked value, then take this one. in this data set, first quartile is 20.8. And then if results is 2.5, 4.5 like this, 0.5, then the same as the median. When you get the median, add the two adjacent numbers and divide by 2. So in this data set, first quartile is 31 plus 35 divided by 2 is 33. And then if result is 2.75, round up, 2.25, round down. So this case, third ranked value is first quartile, so 35. If the result is like a 2.25, round down, and then maybe second one. And percentile, similar to quartile, using this formula, we can get percentile, like 90%. So upper 90%, that means in 10%, something like that. So using this formula, we can get. So example here. So first, we need sort from smallest to largest, like this. And then using the formula, if we want to 25%, lower 25, upper 75, so 15, the sample size plus 1 times 25% divided by 100, fourth ranked value, then 75%, 15 plus 1, 75 divided by 100, and 10-second ranked value. So this one is the same as Q1 and Q3, 25%, 75%. And next one is box plot. So using first quartile, second quartile, or a median, and third quartile, the smallest to largest, we call that 5 numbers. 5 numbers is smallest, minimum, Q1, Q2 or median, Q3, and largest, maximum number. Then find the 5 numbers and then draw. Looks like a box, so we call this box plot. So using this box plot, we can describe our data set graphically. So example, if minimum smallest is 13, Q1 is 15, median is 18, Q3 is 22, and maximum is 30. Then we can draw a box plot like this. Then when we, after draw a box plot, then we can draw, looks like distribution. I will use so from median, looks like this. So from median, right side is longer and left side is shorter. So using this box plot, we can describe our data set graphically. Skewness, symmetric, like a shape of data set or a shape of distribution. Symmetric, positively skewed, negatively skewed, or we call positively skewed as right skewed, left skewed, because from mean or median, this side is negative, this side is positive, standard deviation or z-score. So positively skewed means right side is longer. Negatively skewed means negative left side is longer. And then bimodal, there are kind of two peaks. This one is only one peak. So symmetric, bell shape from mean, left and right side, the same size. And then positively skewed, right skewed, from mean or median, right side, from peak, right side is longer. So, and positive side, so positively skewed or right skewed. From peak, left side longer or negative side is longer. So negatively skewed or positively skewed. Left skewed. And then bimodal, there are two peaks. Bell shape, if box plot from median to smallest or Q1, Q3, the same distance, then bell shape and symmetric. If we draw box plot, then from median to smallest, compare median to largest, or median to Q, median to Q3, Q1, Q3, longer distance, smaller distance, shorter distance, then left side longer, so negatively skewed or left skewed. Box plot, right side longer or positive side longer, right skewed and positively skewed. And kurtosis, the distribution shape, another shape, if kurtosis, the index is 0, then kind of normal distribution, then normal peak. So mesokurtic, we call this shape as mesokurtic if kurtosis is 0. Then if kurtosis index is positive, then this one is this distribution is relatively narrow and then high peak. So we call this chopper peak, leptokurtic shape of distribution. And then kurtosis is negative, Then the shape is now wide and then short. So heavier tail. Relatively, tail is heavier than it's not high. So we call this shape as platykurtic shape of the distribution. And describing the relationship between two variables, if we have two variables as like x variable, y variable, then we can use this kind of graph. Then x variable, y variable, scatter plot. So after drawing a scatter plot, if we can see something, a trend, this one is a positive relationship, negative relationship. If we can see clear direction like this, then strong positive, strong negative. We can see a direction, but not clear, vague, then weak positive. About this one, weak negative. And then we cannot see direction, then no pattern. We can see direction, but it's like curve, and non-linear pattern or curve linear pattern. Okay, I will use data, example data. This data on Moodle. So you can find this data on Moodle. On Moodle, you can find this data description example data. Okay, take a 5-minute break. Actually, it's 7-minute break. I will be back 7:10. So during this break, prepare this, find this file and prepare for practice. Okay, I'll be back at 7:10.
Is this your note?
Okay, I'm back. Here, example 1, data. Looks like data size, sample size is now 42. So we can use formula to find the mean, standard deviation, variance, and so on. But on Excel, you can use data analysis function. Under data tab menu, data analysis. If you don't have this data analysis tab, then you need make it enable. Click file, options, and then add-ins, and then go. Then if this is kind of default, then if it is unchecked, then you can see the data analysis. So check this one and then OK. Then you can see data analysis function here. So click this one, and then the mean, standard deviation, and so on, they are descriptive statistics. So click this one, and then OK, highlight, and then click OK. Then this one asks the range, specify the input range using click, and then hold your button, and then dragging down until the last one, or click first one, release button, and then you may use the shift on the keyboard, shift and control key, push simultaneously, and then the arrow key, down arrow key, then you can specify until the last one. Say again, click first number, then shift control key simultaneously, and then arrow down key, down arrow key, then specify like this. Or just click first one, hold your button, drag down to the last one, and specify like this. And then this data is column data, so column data. And then if the first row is like a label, then you should check label in first row. But this data doesn't have label, so uncheck this one. And the output range, you may specify somewhere like this, or new worksheet. I will display the result here. So output range here, and then you need summary statistics. So you need to check whatever you need. So click this one and click OK. But what's the problem? this file again. Up range, v1, and summary. So this data says, something wrong. Do it again. I will do it again. Data analysis. Okay, that's good. That's good. Okay. So mean, the average is 4.57 and median is 3, mode is 1, and standard deviation is 3.41, variance is 11.66, and kurtosis is negative 0.101, and skewness is 0.92, and range is 13, minimum, maximum, and so on. So from this kurtosis and skewness, this one is negative 0.01. So this one is negative, but not much. So I can say from this kurtosis, if it is 0, then the shape of this distribution is mesokurtic. Negative is, if the kurtosis is negative, then platykurtic shape. So very small. So it can be almost based on kurtosis index, we can say almost normal peak. It is negative, but very small, so almost normal peak and then mesokurtic shape. And then because this skewness is positive, closer to 1, so right side longer shape, so right skewed or positively skewed distribution. And then using formula, we can find the Q1, Q2, Q3, and so on. So 5 numbers are like this. If we use the regular data analysis, Excel data analysis function, then the output information is limited like this. But if we use other add-in, the name of add-in is Megastat, then we can get more information about data. So this Megastat is add-in, Excel add-in. That add-in is on Moodle. I uploaded that one. This one. So download this Megastat somewhere. Download this one somewhere. Let's see where, how will I download this one? Then I will download this one somewhere in my the download in my class. Then go back to Excel. I have the Megastat here, but you don't have this menu tab. That case, after download that Megastat add-in somewhere in your computer, then click File, and that Megastat is add-in, so click Options and Add-ins and go. Then you don't have this Megastat because you didn't add it. That case, browse. Then I have a Megastat somewhere. So find if you download that Megastat add-in somewhere like download directory or somewhere, then find that file and click that file, Megastat, and then click OK. Then yes. Then Megastat appear and then automatically checked. Then OK. Then you can see Megastat menu tab under data menu bar. And click Megastat. Are you doing okay?
Yes.
Okay.
Yes.
You have the Megastat
Yes, we're
tab?
good.
Okay, good. Then click Megastat. Unfortunately, this Megastat doesn't work in the Mac. This one for the PC. So click Megastat and kind of menu window. Then we need a descriptive statistic. So again, click Megastat and you can have this menu window. Then click descriptive statistics. Then you can get another window. The input range, the same. Specify input range by dragging down or using shift control and down arrow. And specify input range. And then this one doesn't matter if there is the label or not. Then default, mean, sample variance, and standard deviation, minimum, maximum, they are default. Then if we need median quartile, then check. If we want a box plot, okay. If we need a dot plot, then okay, click. And stem and lip, click. And we need skewness and kurtosis, click. And then click OK. Then we have output results. So count, sample size 42, mean is 4.57, standard deviation and so on, minimum, maximum range. And skewness 0.93, kurtosis 0.02, negative 0.02. And then first quartile 2, median 3, third quartile 7. And maximum, minimum and maximum. So 5 numbers are minimum, first, second, third quartile, and then maximum. They are 5 numbers. Using 5 numbers, we can draw box plot like this, and dot plot, and stem and leaf. So lower number, more dense, and then a bigger number, larger number, shallow. So looks like this. So longer right tail. So skewness is right. So using this output, we can describe our data set like this. So here, example 2 data. Try yourself. Then let me know if you can do it or not. Okay, I will give you 3 minutes to do this using a megastat. Describe this example 2 data set. Are you doing now?
Yes, sir.
Okay, good. Okay, let's do it together. Click megastat and data statistics and specify range. I will use shift control and then down arrow key. Oops, it doesn't work. Oh, it doesn't work. Yeah. For megastat, that key, short key doesn't work. So dragging down Oops. Okay. Then we need a median, box plot, dot plot, stem and leaf, and skewness and kurtosis. Okay. So based on this, make it smaller. So we can describe this data. Skewness 0.9, kurtosis 0.8544, and then 5 numbers are minimum 6.54, first quartile 6.82, median 7, third quartile 7.177, and then stem and leaf looks like this, box plot looks like this, and this is kind of an outlier, and dot plot looks like this, and so on. So based on this output, we can describe data set, five numbers are mean 6.54, then Q1 6.825, Q2 or median is 7, Q3 7.177, and maximum largest is 7.97. So based on skewness and kurtosis, positive, so this data shape is right skewed, and positive. So it is like lepto, yeah. It's lepto curtic shape. Maybe this one. Data is right skewed and leptokurtic shape like this. So we can describe our data set like this. Doable?
Good.
Yeah. So using data analysis or megastat, produce output like this, then based on output, using 5 numbers and skewness, kurtosis, you can describe data set. Okay, then, you know, I log in today's Pennsylvania the coronavirus. This is kind of cumulative. So it's like that. Yeah. So using data set and shape looks like this. So more 20 to 29 age peak here, and then shape is right skewed like this. So earlier this shape was like this 50 between 50 to 59 and 60, 69 was peak here, but recently after the school open, more 20 to 29 case increase. So the data set the shape change like this. It was like almost the normal shape, but recently more 20 to 29 age group increase. So data set shape change. Okay, you have individual assignment regarding this data description. This one, question and data. So download question and the data. Somebody already submitted. Okay, so do it and save the Excel file and then upload by October 4th on Sunday. Okay. Have a question? If you don't have a question, then that's all. And see you next Monday. Next Monday is in class and online. So if you want, come to class. Okay, see you next Monday.
Sorry, Dr. Kim, I have a question concerning
Okay.
project. So should we go on and produce our report for the research?
Say again, because your sound is like a howling.
Should we proceed with the research work, like to produce the report and all that?
No, not this time. So just you know, narrow down your research question, okay?
Okay, gotcha.
And then keep it. Then next step, I will ask next and next.
Okay, thank you. Have a good night.
Okay, good night.
See you next week, Dr. Kim.
Thank you.
Good night.
Good night.
Good night.
Good night. Let me.
Good night. Thank you.
Good night.